section 1.5, page 4. So let's go ahead and use this graph to answer the statements to the right to help explain the next concept in continuity. So first I'm asked to find the limit as x equals 1, but only from the left side. So when I'm finding the continuity from, or the limit from the left, it looks like it's ending at a height of 4. Now I'm finding the limit as x equals 1 from the right side. So I'm only looking at this graph. And as I'm following that line, it looks like I'm getting a height of 2. Now, what really happens at the function when x equals 1? It doesn't occur here. It occurs up here at 4. Let's do the same thing for x equals 4. We'll start with from the left. Here is from the 4. And if we're only looking from the left, our graph is coming way down here, and it looks like it has a height of -1. Now we're going to look at 4 from the right-hand side. So only this portion of the graph. And I'm going to travel down. I don't care what really happens, but I end at a height of 3. Now let's find out, where does the function have a value at x equals 4? Not at the open circle, only at the closed circle. So we have a height of 3. Whoops, sorry, this 3 down here. Okay, so now here's what we can find out. Functions can be discontinuous at a point A, but they can be continuous from the right or from the left at A. So what happens is, if the function from the right equals the limit, if the limit from the right equals the function at the same value, just in this case like x equals 4. Here is where I do have an existing point and that limit hits there. So my function was continuous from the right. To be continuous from the left, it's got to be a function that's coming from the left towards the function, and the point occurs there. Now, what we looked at up above is a form of a piecewise function. This is a different piecewise function than visualized from up above, but we're going to use that same concept to solve this problem. The question reads, list all x values at which f has discontinuity, but at each discontinuity, determine whether f is continuous from the right, left, or neither. So I've got these 3 functions, and basically what I need to do is check the x values where the functions transition from one equation to another. And I'm going to check that transition value in both functions, looking for different outputs to determine the continuity. And then don't forget our less than or equal than, greater than or less than symbols mean we have solid dots. So my first 2 functions, the first function goes from basically -infinity up to 0, and the second function starts at 0. So 0 is one of my transitions where all values less than 0 use the sign, and all values of x that are greater than 0 use x squared plus 3. So at my transition point of x, I need to plug that x equals 0 into the limit of the sign for my left piece, and then I want to plug 0 into the other function because I'm coming from the right where x is larger. The sign of 0 is 0. 0 squared plus 3 is just 3. These 2 values are not equal, so my function is discontinuous at 0. But what does the function equal at 0? Because we have less than or equal to in the second line, which is the x squared plus 3 function, and that was my right-hand function for x equals 0, my function is continuous from the right at x equals 0. Our next transition point is a 2. So looking at x equals 2, we need to take the limit on the left, which would be the x squared plus 3 function, and the limit from the right, which would be the x plus 5 function. I'm going to plug 2 into both functions, and I get 7 as the answer for both of them. So this means my function is continuous, but the way the question was asked, find the x values that have discontinuity. So the way your WebAssign will better be worded and a quiz or exam would be worded is, state what happens at 0 and 2. So we would state the function was continuous from the right at x equals 2, and there was no discontinuity at x equals 2. I think I said 2 when I meant 0 for the previous one. Okay, so taking that process, we can extend it on to turning functions into continuous functions. So we're going to find a value c to make a continuous function at those transition pieces. This particular graph is only from negative infinity to 1. X is less than negative 2, goes down to negative infinity, but when x is in between negative 2 and 1, the function stops at 1. So I want this transition point of negative 2 to have the same limit on the left as the same limit on the right. I need these two limits to be equal. So basically, I need the two functions to be equal when x is negative 2. So I'm going to plug negative 2 into the first function, negative 2 into the second function, but we were asked to find c because our function has a unknown constant in this equation, this function. So I can go ahead and combine like terms, subtract the c to the other side, and 4 minus 1 is 3c. So when I divide both, I find that if c had been negative 4, then this function would be continuous on the entire interval that is given. The next problem is just a little bit harder version of that same thing. I'm asked for f continuous. I know I'm setting the x minus c equal to the cx squared minus 3. Because the transition value is 0, I'm plugging 0 in wherever x was. And what I'm left with is something easy to solve